Thank you all for joining us this week again. This is week 3 of Professional Machine Learning Engineer, and we are here as Google Cloud Boston to basically go throughout this journey all together. So, code of conduct. As always, be nice, be respectful, participate, and let's just do it together. And let's go. In this session, some examples, questions, and see what we have to do for the next week. Right now, we are on week 3, feature engineering and machine learning in enterprise. There is also a lab associated with this. So I was saying that we spread out the following weeks to every the other week. So the next week wouldn't be actually next Wednesday. It's going to be 2 Wednesdays from now. It's going to be May 3rd. And so obviously the week 5 would be May 17th and week 6 would be May 31st. I'm honestly going with you through all of the content of these training, and I understand that it takes a lot of time. So we hope that by doing spreading out a little bit further, you get enough of time to go through the content of each week. And if you go through everything by the end of June, you would be able to basically apply to win a voucher for your exam. So that's being it. Yeah.
Beautiful.
Thank you. Yeah. Okay, so this week we are going through data ingestion, data exploration, design data pipeline, build data pipeline, and feature engineering. So the whole idea is how to get this data from the raw data and put it together to be able to be fed into a machine learning system. We want to construct the data set and transform it. So how to basically get this raw data and apply different type of transformation to make it ready for the model. Obviously, the model only accepts numbers, so we want to know how to get different type of input data and make them good numbers for our model. Before we move on, I want to challenge you to think about this question for a minute. If you had to prioritize improving one aspect of your machine learning project, which would have the most impact? Using the latest optimization algorithm, the quality and the size of your data, a deeper neural network, a more clever loss function. I give you like 30 seconds to think about it, and then let's discuss it.
We have a lot of responses online. People are unanimously pointing out B.
So we have, I think, so many people who are pointing out to the right answers. If we want to go through the answers one by one, so what does your optimization algorithm do? Basically, it tries to figure out what is the easiest way to find the local minima into your weight space. So it's nice to have the latest, most fancy optimization algorithm, but if you do not have that weight space, it would not work for you. And a deeper neural network, it's not actually always to your benefit. If you do not have enough of data, you do not have enough of basically load to train all of these knobs. So if you make this deep network and you do not have enough of data, so much of them are loose ends and they are not going to come to your benefit. And the last one, which if it was me answering this question, I would be between B and D, is a clever loss function. So I want to put a disclaimer here that it actually comes to your benefit if you work with it, but it never comes even close to having a good quality data. Because if you have garbage in, it's garbage out. Okay, so this is the slide that I was looking for, like a slide before this. I thought these two are back to back. When I was talking about the constructing the data, basically we are talking about how to collect efficiently the raw data and how to explore this data to figure out which ones are the feature that we are looking for and what we can use to identify them. We also need some sampling strategy and how to split this data. The sampling strategy comes handy because you don't want to use all of the data if you have this giant data set. And for splitting the data, you are considering to have some reserve for testing and validation. And then after doing all of it, you also need to be able to transform this data. This is when you know what features you are looking for, but you want to be able to apply those transformation to gain those features out of your raw data on the go. And that makes your basically input ready for your model. And again, uh, everybody knows, I think that's like goes without saying, that garbage in, garbage out. So if you have good input data, you would get good output. If you do not have a really good unbiased uniform input data, then obviously your model is not working perfectly. As Google is like the best platform, it provides you with APIs and some basically tools for each of the steps of the way. Suppose from the ingest, basically getting the raw data, the ingest stage, it helps you with transferring the data with some platform like Google Cloud Storage or PubSub. So if you have like these batches of data, you can use Google Cloud and storage. If you are using the stream of the data, you can use PubSub. Then you want to explore this data and to realize which part of this data is more important for you. So then BigQuery comes handy. For preparing and processing the data, you can use data prep, data flow, data proc, BigQuery, Google AI, labeling. We are going, actually, you will go through some of the tools that the data flow will bring to you and Apache Beam in this course. And out of these, I want to also mention that the labeling is if you wanted to annotate the data, and it comes handy when you have this giant unannotated data set. So Google has both automated and manual and labeling for you. After the pre-processing, you are in the machine learning realm of the basically Google services. So for training, hyperparameter tuning, and testing the data, you have multiple platforms like Google AI API, Google Cloud AutoML business solution, and you can use AI hubs for predicting and testing your machine. Traditionally, people, like when somebody was writing a code, it was for them to identify unit tests. The idea was that you have this input data and you have to generate a function, quote unquote, the code to basically take this input and generate the proper output for you. So the question, and the good engineer was the one who would generate good unit tests, because the unit test would identify all of the corner cases and make sure that your code would not break in any circumstances. But in our days, with machine learning system, now we want the data to handle the whole thing. So we do not have that algorithm in the middle. We are just training that algorithm. We are giving a machine enough of data to build that algorithm for us to give us the output. So now the what we used to do with the unit test comes to identifying and understanding and validating the data, because we cannot easily make sure that the machine works properly. Again, our beautiful Google comes handy. So Google provides us with TensorFlow Extended, which, as we discussed it before, covers the whole basis from data ingestion, data validation, transforming, the beautiful keras, model analysis, serving, and logging. Before we move on, I wanted to point out, because why I love Crash so much. If you were working with TensorFlow like in 2016, you had to calculate the depth, width, and height of each of the tensors. And one line of mistake would mess everything up. But then Crash became really popular, and now you are just introducing what is the output size, so it makes the whole thing seamless. Okay, why input pipeline API? So why use TensorFlow basically to generate the input data? Data might not fit into the memory. This is a type of problem that if you are like using a giant tabular data or a lot of image data, you are definitely facing. If you are not using the TensorFlow APIs, you have to basically load all of it into the cache of your PC or anything else that you are using. And if you are having giant data set, then you cannot fit the whole thing to be able to train a model on all of the data. You also might require some randomization and pre-processing. So again, if you are not using this pipeline, you have to make all of the pre-processing and store them somewhere in your PC and then use them at the time of training. The problem that it brings is it takes away the randomization of it. So you are building it once and for all, and it's there. So you are not constantly updating it. And obviously, if you are not using the TensorFlow API, you are not having as efficient of utilization. And there is always there is always a entanglement between the loading and pre-processing of the data. So all of them has to happen at the same time. But with using this input pipeline, all of them would be sorted out. Let's see how. In general, TensorFlow dataset object allows you to extract, transform, and load the data seamlessly. It allows you to read the data and parse it. It allows you to generate this text vectorization or image transformation or any other type of transformation that you can think of. You can just fit it in there and map using it. And you can obviously load it to your training system. Let's go through an example. This is the how-to. Obviously, import a TensorFlow and then generate a data object. So tfdata.tfrecord dataset takes the object and reads it from any type of storage that you have. So it can be from your personal system or it can be somewhere in the cloud. Then apply basically dataset map takes everything that you put into that pre-process function on the top and applies it to all members of your data set. And sky is the limit for whatever that you want to put in that pre-process. So there is no limit. You can do everything. And it happens on the random. So every time that you are doing it, you are applying something new. If you are sampling your data, every time you are sampling something new. If you are applying random augmentation, it will change every time. And then it batches the data for you. So if you are familiar with TensorFlow, you know that every time you are feeding it data in batches, and the dataset object has this batch attributes that basically breaks down the batches for you. And if you were using a model.fit train set, now you can just give it this dataset object, which is not taking any space for you, just like feed it in and it understands to go through all of these steps when it's training. But let's see the magic comes to the picture. Right now, what is happening is you are preparing the data in the CPU and taking it to the GPU training. So for part of time, your CPU or your GPU is idle because it's waiting for the next batch of the data to come in. But instead of that, you can basically squeeze all of them together. So constantly prepare the data so they are ready. And while you are working on your GPU, then the next session of the data would get ready. To do that, when you are basically generating all of your data set pipeline, you are adding this one extra line of code that does the prefetch. So by prefetch, you are collecting these batches of the data to go through training ahead of time. So you are using basically saving some time. Another piece of magic that you can apply is to have parallel transformation. So instead of basically having all of them in one all of this processing to happen once, you can have them happens in parallel, so it saves a lot of time for you. And lastly, you can read. So far we made the mapping parallel, and we also use the fetching. So we save so much time, but still we are bounded by how quickly we can access the storage to get this input data. And by applying by basically collecting this data in parallel, by reading this data in parallel, we are even making it faster. So in multiple level, one from the recording the data, one from mapping the data, and one by prefetching the data, we make the whole thing in immensely faster. We discussed about how to, yes.
In the previous slide, you mentioned that the buffer size is x. So is that a function of something, or is that?
Those are numbers.
Okay,
yeah, you can put any number that you want. Other question? Sorry, I was just like looking here. I didn't even notice. All good? Continue? Okay. So TensorFlow data validation. So far, we discussed how to process this data, but now we want to see how to make sure that the data is what we think this is. TensorFlow data validation is actually like a widget in your Jupyter notebook. So instead of like writing all of this code or using any of the other Google platform services, now you can have it inside your Jupyter notebook, and it gives you information on a huge amount of data without actually really taking much. It helps you to understand, validate, and monitor all of the data without basically making you to write the whole code yourself. I strongly recommend to go through it and give it a try. I never been using it myself, but so I'm learning with you, and this was an interesting thing for me because it's really seamless. As long as you have the TensorFlow on your system, you can just install it and it works really, really nice. Okay, the good part, feature engineering. Before we get into the feature engineering, let's see the type of features that you might come across when you are building a machine learning system. The simplest type of the features that you can think of is the numeric features. These are the features that they are numbers, and the magnitude of those numbers have value for you. So if some number is bigger than the other, they actually mean something. You keep them as is, so you are not like trying to change them. You scale them, you play with them, but this is still the simplest type of features. The second one is the categorical features. These are when you are dealing with a string, you are dealing with labels, so red, green, blue. What you are traditionally would do with them is to turn them to one hot encoding. That is, you generating a vector with the size of your vocabulary list, and basically turning the cells of those vectors on and off based on the presence of the feature that you are looking into. So if you want to have a vector for green, the cell for red and the cell for blue would be 0, and only the cell for green would be hot or 1. And it gives you a sparse representation of your data. apart from that is when you want to bucketize your system. Here you are dealing with numeric feature, but these numbers, they do not have or you do not want to carry all of the value. It doesn't have that much of it doesn't add that much value if you care about each of those floating point numbers. Instead, you are reducing the resolution of this number to some features, some basically labels, some strings, and turn those strings into one hot encoding. So suppose you have a number for the waist measurement, and you can turn it to medium, large, or extra large based on the size ranges, and turn those string into one hot encoding. Now that we have the number, the categories, and the bucketized, you can apply feature crossing, which is a method to allows you to basically put a weight on combination of the features. And don't let it to confuse you. Feature crossing can be a feature with itself when you want to know the square value, the square of a feature value, because you are not caring about maybe the sign of that value. So for feature crossing, you can apply one hot encoding, or you can generate embeddings. So obviously, if you are doing one hot encoding, then the number of the cells in your vector would be increased for the number of the features.
Pretend that they know what this means on the board, and oh yes, yes, yes. Yes. Thank you.
And generating an embedding is for dimensionality reduction. So basically, you are taking your information and you are generating a vector to represent it. Let me here intro a little bit stay on embedding. So embedding is to make these vectors, but this vector should make sense. And the easiest way to think about them, in my opinion at least, is that suppose you are generating a word vectorization, which is a type of embedding. So you are taking the word and you want to give them a place in a latent space, in an imaginary space for every possible word. If you have two vectors for women and men and you subtract them, so vector of women minus vector of men, the subtraction vector should be equal to if you have a vector for queen and a vector for king and you're subtracting them. So when you are doing the embedding and you are generating this latent representation, the meaning has to carry into your latent space. Okay, and finally, the hashing. Hashing comes handy when you do not know how many vocabulary you want to basically you want to have, and new information might come. So instead of building this vector and giving each of these vocabulary a space, you are going to quote unquote make a fingerprint for each of those values and categorize them based on the hash value of those fingerprints. The easiest way of thinking about it is imagine that you generate a number for each of these values, and you put every number depends on the remainder of them by 10 in one group. So if the remainder is 1, then all of them goes to one group. If it's 2, all goes to the second group. So sky is the limit for the input. So you can have 100,101 and still all of it goes to the bucket number 1 because the remainder would be 1. Okay, these are how, yes.
It says limit vocabulary size. What does this mean? It was supposed to have infinite categories, so isn't it contradicting it?
So the size of the buckets that you are putting it, so that's the vector, right?
Okay. So the vector is limited size.
It's limited size. So if you are if you are calculating the remainder by 10, you only have 10 buckets. That never changes. Yeah. but it allows you to have infinite categories because you always can make a hash value and drop it in one of those buckets. Good. Continue. You're too quiet, and I'm worried that maybe I'm too unattached. So if there is question, let me know.
Sorry, just on the embedding, what determines how many columns we have? Like the categories determine how many rows, but what determines how many columns we have?
Can I be honest?
Sure.
I don't think that, at least in my brain, the embedding doesn't look like what it shows in this
Okay.
picture. That's why I brought up the example of men versus women over king versus queen.
Okay.
Because when I'm talking about an embedding, I would use a deep neural network, and it's a latent space. So
Okay.
Well, another part of that answer is whenever you do one hot encoding, that's going to blow out the number of columns immensely,
Okay. Gotcha.
potentially. So some database systems may not be able to handle that.
Gotcha. I just didn't know whether they use any of the kind of sparse tricks you see in indexes to reduce the
Yeah.
overall space.
Because what one hot is like kind of electrical engineering term, I think, but it's really what you're doing is you're just putting a column that's a binary value, true, false, for each value in the original set, right? So if you have 10 colors, you're going to have, you really only need 9 columns to represent 10 colors, because if they're all off, that means the one that you didn't put there it's that color.
Gotcha. Okay.
White could be not encoded at all. So if everything's all 0, 0, 0, 0, then white could be like default. But that kind of thing, that really blows out the number of columns a lot.
Got it. Good question. Is one hot encoding also a good thing to do for labels that are categorical?
by labels, you mean the output?
Yeah. So instead, like if you wanted to classify the
Yes.
pants, so like that's also, or do we? Because I've seen examples where they just are like, oh, we'll just call these 1 through 3 because we just give them numbers. But then the training was saying that you want the numbers to mean something.
I'm answering it based on experiment. You never want to give numbers because all of these systems are matrix multiplications. So numbers have value for them. This is the reason that you are not giving. You are doing one hot encoding. You are not giving 0 to 10 in the feature list. For the same reason, you are not giving number with magnitude for the labels, for the outcome labels. So the MNIST data set, which was 0 to 10, even for that one, you would give it vector of size 10, and then from 0 to 10, one of them would turn on based on the output numbers. Did I answer?
Yeah.
Please be honest. If it doesn't make sense, let me know. Okay, if there is no other question, let's go further. Okay, there are a few. There is a question there? Or? Okay. There are a few methods that come really handy if you are dealing with numeric values. And basically, it's nice to have them in your arsenal. Linear scaling is the first thing to apply. And this is usually when you have these tabular data and they are not in the same range. So suppose one of them is the height and the other one is the age, and the height is in centimeter. Especially if you are using more traditional machine learning methods, you want your features to fall into the same range so they have the same impact on your output. So the way to do this, to put them in the same range, is to subtract each member of your feature from the minimum value of that feature category and divide it by the range that all of the value exists in. So if you calculate it in your mind, the smallest value that this equation can generate is a 0, and the biggest value that it can generate is a 1 for x minimum and x maximum respectively. And what it does for you, it's for every value that you are feeding to your system, now it's a number between 0 and 1. So no matter what, the impact of this feature would be similar. Another interesting technique you can use is the clipping. So that's basically if you are having really big numbers or really a small number, but the population of these really big or really small numbers are minimal. So basically you have some extreme outliers. So you are going to say, okay, all of this tail, I will call them big, and that's it. You also can use log scaling, and that also handles the problem of having a basically high head and a long tail, but it approaches the problem differently. So now instead of just chopping the tail and say all of it can be a maximum or a minimum, it thinks about them as their power. So everything would be more in the same range because now you are dealing with the power. And just to give you numbers, 100,000 and 1,000 are so different from each other, right? But 100,000 is 5 and 1,000 is 3. So they are more comparable when you are making the log from them. And the last one is the z-score. And the idea here is to make the system with a mean of 0 and a variance of 1. So you are subtracting everything from the mean and dividing it by the variance. I would say this is the most practiced because it makes the system, at least they say that it makes the neural network works better when you are dealing with a mean of 0 and a variance of 1, particularly when you are dealing with images. So it's a common practice to divide everything by 255 and subtract the mean.
So for the z-score, most things would be like plus or minus 3-ish. And
Yes.
most is going to fall
Right.
from 3 sigma. Okay.
Yeah, Z-scores used very commonly in financial analysis, like stock prices, things like that, because you want, like you said, for other types of data, you want things to be comparable, right? So if you want the stock price of IBM is zigzagging over some range, you want to make that comparable to Google's variation and absolute numbers. So the Z-score is really helpful for that.
Definitely. It shows that my experiments is more with images. So everything that I see, I go for images. But thank you. Everybody here came online, right?
I assume so. Can y'all hear Norbert online? I like math. Thank you.
Thank you.
Was that a yes? 'Cause
Multiple yeses.
okay, and
Perfect.
the meeting also.
Okay.
I'm not sure what mic is picking me up.
No, it's the room mic. That's
Okay,
got it.
that's good enough then, because I'm also in the meeting. I could just unmute. So
No, people can hear you fine.
okay, cool.
Perfect. I just don't want anybody to lose this expert information.
I got a question back here.
Yes.
So for the range is usually from -3 to 3 range for z-score. So what do we define as an outlier in the z-score? Like we
You
say,
can go over 3, right? You can have more than 3 sigma, but
okay, but it's usually between the range. So in practice, what do we see? Like what range of the value usually like?
I would say that's really that's a domain specific question. So you need to look at your data.
Okay.
For a normal,
It depends how your data is distributed.
Right.
I mean, not everything. Many things are normally distributed, but not everything certainly.
if it's normal,
When-
then 99.9% will be within.
yes.
But
Plus or
every
minus.
time I normalize something or scale something, I always have the doubt like, what do I consider as an outlier? Like after scaling and I look at the value and see something is greater than something, do I consider that? Do I drop the value? What? How do I?
So the idea of 3 sigma is that if you make the distribution, it should fall 90% of your data should fall under the 3 sigma. If you make the sigma equal to 1 by dividing all of your data by sigma, so everything would fall between -3 to 3. So far so good. We are imagining, we are basically interpreting that 10% of the data would be outside of it. But what we consider quote unquote outlier, I wouldn't ever put a hard line there. If it was me, I would definitely go and check out these outliers. For image data, if there isn't, the outlier can be a person who is basically imagine somebody is hidden by the wall. I cannot see them perfectly. That can be an outlier for my system. Do I want to consider it or not? Depends on the application that I'm using. But if you are trying to generate a medication for children, and you have this one child who is underweight or overweight, so maybe don't want to consider it. It's really domain specific.
When you say like logarithmic, for example, a logarithmic would be like if you're dealing with like sound, if you're dealing with intensity, things like that can like be many orders of magnitude, like 12 orders of magnitude or something. Then that's when you want to just try to really constrain it with a logarithm.
I have a question. Are these strategies to save on computation, or actually, like, even if we had unlimited computational power, we'd still want to use these for our machine learning model?
Well, I guess there's one thing in general when you run a computer. Remember, you have like epsilon and you have machine precision, right? So like, if you can make all your numbers fit in one small box, you don't have to spend as much room trying to store your numbers, right? If you normalize them all, now you only care about like 5 decimal places, whatever, right? Instead of saying I got something that's going from like 10 quadrillion to 1 pico, right? And then now you have to spend a lot more space storing your numbers as well. So there are some benefits to just normalizing everything to one small range.
Right. So I totally get that, but I just meant in an ideal situation, like, does this also just help with machine learning algorithms because it works better with data that isn't so unique or is more normalized? Is it just a space and computation saving methods, or is it like actually good for machine learning?
Like, I guess one thing I was throwing in, I'm sure Roy knows far more than I do, but there's other considerations like overflow of numbers and things like that. And all I have to start summing stuff, and I have huge numbers. And then like I'm going to overflow, underflow, things like that. There's other considerations.
So here I'll give you something that might help with the intuition. If you consider there's a commonly worked example is doing a regression analysis on the sale of house prices, right? So we've all probably seen that one. So if you look in a city and you look at what factors determine the sale price of I want to predict the sale price of that house. The number of bedrooms goes into that, the number of bathrooms, the square feet, and let's just stick with those. So those things are widely very, disparate in their ranges, right? So the square feet is like 2,000 square feet, and the number of bedrooms is going to be 2, 3, 4, something in that range. And so those things, you don't want to just compare those directly because if you just did it numerically and put that into linear regression, right, the square feet would just dominate and the other thing would just be lost completely. So that's why you normalize, you like either bring everything to 0 to 100 or 0 to 1 or some, pick some range and make them all comparable so that the factors can have at least a chance of being equally weighted. Does that make sense to you?
Yes, definitely. Yeah. I think that's the
so
just to wrap the
my answer is I don't care about the computation. I don't care how much compute power it takes to run the regression model. I just don't care. The scalability of cloud is just enormous, right? So that's not what we worry about, in my view.
To add on, like there are some algorithms like k nearest neighbors which require scaling because you have data all over the place, and k nearest neighbors works on take a distance. Based on the distance, you calculate if they are a neighbor or not. So everything must be in scale. It should be relative to each other such that it actually calculates if it's in the same group or not. So there are certain algorithms. I study data science, so we just had this in class, so that's why. So there are certain algorithms like k nearest neighbors which need data to be scaled for it to work.
And that's a great point because what you're doing there is really you're defining you're defining what it means what's the word distance mean for you, because it's not just it could be literally Euclidean distance like from X to Y, but many other things like you could consider this house price thing.
Yeah.
You could consider the dollar range, the square foot range as a distance, so to speak. But you have to scale it so that it kind of fits with the other things that you're looking at.
Move on to the next slide. I don't want to
Yes.
Yeah.
So if you
This
check out
fix.
every method that we discussed for normalization, suppose our raw features are what we are seeing on the most left. If we scale the whole thing, basically scale it to 0 to 1, then the whole data would be squished from 5,000 to 45,000 to 0 to 1 as expected. If we are clipping it, then we are basically adding the long tail to the last value that we are deciding. So in this case, we are deciding the last value to be 40K. Everything after the 40K is on top of what was 40K. And this is the reason that in the clipping figure, in comparison with the raw feature figure, you do not have that last bump, but the bump for the 40,000 is a little bit taller. For log scaling, now we are calculating the power law for each value. So now the population, the value is not what we used to see. We are not saying 5,000 anymore. We are not, basically all of those numbers are now smaller, and I think they use the regular like logarithmic. And finally is the z-score, which puts everything from instead of whatever number it was from -1 from sorry it makes the mean to be 0 and the variance to be 1. So this is the reason that you see a lot of the population is between -1 and 0, but we have some almost similar population, but not as a little bit more sparse between 0 and 4. Okay, with that being said, now we are done with feature engineering, headed to transforms. The question that comes to mind is, where do you want to apply this transform? So we talked about all different methods of feature engineering, but where should we do this feature engineering? Should it be when you are training the model? So basically your model gets the input and that input only, and apply all of the transform on it. What if you are trying to do something like a rolling average? So you are requiring some information from the previous or the future. What if we use this feature creation part, which is the TF transform? Let's not see that part for a second. The other approach you can use is to do pre-processing. So everything is in a pipeline. It can do everything, but then it is actually happening prior to your machine learning. The best of both worlds, if you have something like a TF transform that, thanks to Google, we have, that it has the efficiency of if you were doing this transformation inside your machine learning model, but also allows you to see future and past information. So if you want to do some sort of processing on the temporal data, that allows you to do that. In addition to that, previously, if you were doing it outside of your machine learning system, you need to get the input, do the transform, generate the type of features that you want, and then pass them to your machine learning system. However, if you are doing it, then basically either you have to tell your customer what you are doing, or you have to find a way for them to do exactly that. So that is, if you want to get information from your customer, you have to let them know exactly what type of information you are extracting from the data that they are providing to you. The reason for that is they need to apply the same type of transform to be able to use the model. So in the previous graph, on the top, you have the input, you do your pre-processing, you train the model, everything is good. You have this model right now. For your client to be able to get any result, they have to do exactly the same processing. So you need to declare them. Instead of that, the good practice is to apply every transform that you want inside your machine learning method, but not as a TF model, as a TF transform model. So it would be not exactly inside your model, but when you are generating the data set as lambda function. I strongly recommend you work on the lambda function. It makes life much easier if you get the gist of it, how to apply it. But it's exactly as if you are using the lambda function outside of your TF model. It will be one layer, so it gets the data, apply all sorts of transform, and you do not need to do any transformation, any feature engineering outside of your model. Basically, the whole thing falls into one umbrella. Now you're just getting all of the input information. The transformation happens inside of your package without really impacting your machine learning model. Yes, we are finished by this part.
Yay.
One question, and that's actually the question that you brought up. So different cities in California have markedly different housing prices. Suppose you must create a model to predict the housing price. Which of the following sets of features or feature crosses could learn city-specific relationship between rooms per person and housing prices? 3 separate bin feature, bin latitude, bin longitude, and room per person. 2 feature crosses, bin latitude and room per person, and bin longitude, room per person. 1 feature crosses, multiply everything by each other, and 1 feature crosses, multiply latitude, bin latitude, bin longitude, and room per person. Sorry. Please. They hate me right now because it. Please think about it for a minute and then let's discuss it. Any idea? Do we see the result?
Of what?
Like anybody sees anything? Says anything?
Yeah, we have one person saying E is the answer.
Well, I think latitude and longitude are inherently connected. That's why I say people that live at this parallel across the state tend to, you know, when I'm buying a house, I don't say it has to be at this many degrees latitude, you know.
Yeah.
Exactly.
So
My guess would be D.
the answer is actually D. So obviously the exact number of latitude and longitude doesn't make any sense because nobody cares. So you want to bin them. So you want to have these categories to have a rough estimation of where in the city we are looking into. And you are binning, categorizing or bucketizing basically the room per person, because after a number then it doesn't make sense. So you want to put everything in a smaller buckets, and you'll do one giant feature crossing. So for now you have a value for the location in the city and the number of rooms. So basically you are asking your model, if we are in this particular location in the city and we have this many rooms, what is the range of the price? So that's why D. Q&A. Any questions here, there? Good, happy? For this week, we have feature engineering and machine learning in the enterprise. And as I mentioned, the lab is not working. So just do those 2 courses. And next session would be 2 weeks from now, May 3rd. Okay, so now let's do the one of
So
the.
you just want to speak to that for a second, just to make sure everybody that we're not going to keep going every week, right?
What's up?
So
Every other week.
Yeah, I don't know if we've spoken to that yet.
Yeah, we've mentioned it. We'll just since we're on this slide, we'll cover the 2 related things on here. As a reminder, Roy pointed this out. The week 3 on the slide shows a hands-on lab practice. The link does not work. You don't need to do it. It's not part of the requirements for this course. So you can just pretend that's not there and not worry about it. and then we have changed the schedule. So week 4 is going to be 2 weeks from today. And then week 5 will be 2 weeks after that. And then week 6 will be 2 weeks after that, which is May 31st. So May 3rd, May 17th, and May 31st are the next 3 events, the final 3 events in this series. And so hopefully that will give folks a little more time between sessions to try and complete all of the lab material, because it's quite a bit, even if you don't have a full-time job. It's like a full-time job, and then most of us do. So so we hope that change is good for folks. So just as a reminder, we will not see you here next week, but we will see you the following week on May 3rd.
Yes.
Great.
Great. Thank you very much. So I'm going to go through one of these labs with you. Which one did I just? Oh, yeah.
So this is, just to be clear, this is a course.
Yes,
And the course has videos and labs, right? And we're doing one of the labs within this course.
exactly.
Are we gonna step through it?
Yes. But I'm gonna cheat and I'm gonna go through the solution instead of going through the thing.
Oh,
Yes.
Sneaky. Since we're sharing the window, guys, I'm just gonna tweak this so we can see both of them at the same time.
Do all the labs have solutions, or is this?
they don't all have
Some do,
a
some
video.
All of them that have so basically you are getting this GitHub repository, and this GitHub repository has solution for every lab.
That's
But
correct.
those of the labs that they are not inside the Jupyter notebook, they don't have a solution.
And this is the, I believe it's the same GitHub repo that is called machine learning something,
Yes.
machine learning training something.
Yes.
Yeah, that's one that they've been building on for years,
Yes.
actually.
I have multiple, so I think that's dumb. But every time I get a copy of it on my personal computer, because I think there are so many good information there.
Oh yeah, and you just instead of next time you do the lab, you just do a git pull to get the updated version. You don't have to reclone it every time. I do the same thing.
Oh, I see.
But what Roy pointed out there is key. Like in many of the labs, you have to clone a repo and you CD into a certain directory where they provide you with like a work in progress, and then you have to do some stuff in that directory to make it work. And then if you get it successfully, it's like, great, you completed the lab. But then there's another directory in the repo that has the completed version of that. So if you're like really struggling, how do I get this Python code to do the thing it's supposed to do? I'm not quite sure. You can literally go see what the solution is as well. So that's all in that repo.
And a lot of the labs now have wizards that check your progress. I don't know if this one does, but
Yeah,
This one
it's hit or miss.
Yeah.
It really depends
the newer ones.
somewhat
tend
on
to have
like
it.
who wrote the lab
Yeah.
and whether they added those features in. But it also depends on what the nature of the
What the
lab is.
material
Some of
is.
them are it's not quite as easy to check. Like
Yeah.
when the task is go make a bucket.
Yeah, I
with
was
the
gonna
same
say,
name
go
as your
make a
project,
bucket.
that's easy
Boom.
to see if you did that.
Check. It's
But
done.
some of them are a little more opaque.
Yeah.
Like check the BigQuery logs to make sure you ran a query that looked like this, or something.
Yeah.
So they don't all have the checker mechanism.
Cool.
Okay. So let's start with the lab. Obviously, you start a lab, it gives you 1 hour, so it shows that it's not that as big of a lab, but give it really the time that it requires. You're signing in an incognito window. So
I think we said this before, but good idea to, before you hit the start button, get your coffee, hit the restroom, plan on staying there for that hour while the lab timer is running, because usually you have enough time, but not always.
I didn't even follow this direction yesterday. I started the lab and I was like, I meant to get a snack, and I ran to go get a snack and try to make sure I still have time to finish the lab. So yeah, take Norbert's
After you've
advice.
done 30 or so, you kind of get used to it.
Okay, so we basically did the first part of it. We are inside the lab, and now let's launch the Vertex AI, and that would be your go-to whenever you need a Jupyter notebook. So enable the recommended APIs, and then there should be a workbench in the side. Choose user manage notebook because you want to have everything manageable by you. And there should be a Jupyter notebook somewhere. Yeah, new notebook on the top. It gives you what type of notebook you require. So I'm reading task 2, sub task 2. New notebook, TensorFlow Enterprise, TensorFlow Enterprise 2.6 without GPU. So it's going to be here, 2.6. Okay, guys, I'm really struggling because it comes the other side of it. Yeah. Is it this one? No, that's this one.
You can get rid of the recommended for you tab. That will declutter things a little bit with the X in the top right.
Hopefully we don't need it after this part. So give it a few moments to have your instance of a TensorFlow 2.6 without GPU. So a server basically on the cloud. The next.
Can you just click right here?
Okay, while this is loading, basically the idea is that you are getting this repository from GitHub, and every time you are doing one chunk of code from this repository, I recommend having it on your own PC too, because it has so many interesting code that you can go through them on your own time.
It's a public repo, right? So
Yes.
you can grab it anytime.
You can grab it anytime. And now it takes so long, and I'm out of things to talk about, and it's an awkward silence.
But we know that data proc always starts in 90 seconds, right? Except for we heard that's not always true.
True, though, what I generally do with things like this is like I get another tab open and I'm watching other videos and stuff. Like, I'm moving ahead.
Yeah.
I do the same thing.
Good point.
You went green.
Yes. So when it's turned green, open Jupyter Notebook. Open the terminal. This is going to be like the terminal you have on your system, and just clone this repository.
Every time this one. Can you tell me what BQML is? BigQuery machine learning.
Exactly.
That's not one of those giant repos.
It takes a little bit, and it has everything in it. So
It's better than the Chrome repo. Try checking out Chrome's source code. It takes like an hour and a half. So 25 gigs.
Oh, wow.
Imagine checking out the Google source code. They have the one mono repo for the whole thing.
Seriously.
Yeah.
after the whole repository is basically cloned in your system, then on the left side, you would see source, training data analysis, and tutorial. So you, basically you're following this path, which is written for you in the lab. you go to the training data analyst, courses, machine learning, feature engineering, hold on, machine learning, deep dive 2, and then feature engineering. In each of these labs, there is a lab and there is a solution. So instead of doing the lab, I'm going to do the solution. And let's do the first one. So this is the BigQuery ML Basic Feature Engineering Notebook. The basic first step is to install every Google Cloud BigQuery information. And I think you know, but the easiest way is to do Shift and Enter every time. So if you're like me and you don't want to use the mouse, and just like keep going through them, you are importing the TensorFlow and you are checking basically for the project ID to get the data set. So those are not important. Let's get to the interesting part. So the source data set that we are using for this project, let me read from it. Our data set is hosted in BigQuery, and this is the taxi fare data that is publicly available. So basically, this is New York taxi driver. With GCP account, you have access to this data set. So the BigQuery is going to get this data from the Google Cloud for you and puts them into the feature engineering BigQuery data set. And this is what you are doing in this stage, right? And then you want to create the training data. So if you recall, or if you go through the course, it explains to you that when you want to do a machine learning basically system through the BigQuery, you need to do a create, and then you are giving it the data, and you are selecting all of the different labels, basically columns that you wanted to use. And here it just explains to you that it doesn't want to use all of this giant data set, and that is the reason that it used a modular to get about 10,000 rows of this data instead of the whole thing. And the first thing that it does is to take all of this data as a giant without any type of feature engineering and see how it works. Obviously tries to check whether this table is correctly downloaded, and then generates the base model based on this data that you are collected. So you are creating a model, you are calling it, this is a model from your feature engineering data set. You are calling it base model. The type of it is linear regression. It tries to understand or predict the fare amount, and it takes fare amount, passenger, pickup date time, pick up longitude and latitude, drop of longitude and latitude from the data set that we introduced it initially, and we call it feature training data. So this is our baseline model. We want to just beat this one line.
So this is the model we're trying to beat, in other words,
Correct.
as we do our feature engineering
Yes.
and enhancements. And this would be somewhat like the simple heuristic model that we talked about last week.
Correct.
Right.
This is the basic, no feature engineering, nothing model. We want to have a baseline. We want to have this benchmark.
Yeah.
And the hard days are when you built this benchmark and you cannot beat it. That's a tough day. So to evaluate the machine, to evaluate the system, now that BigQuery generated it for us, we are going to use basically a loss function based on the square value of the loss, and we call it RMSE, and you are evaluating the model against that loss function. So we are making it and then evaluating the model against it. So the mean absolute error is 5.21. mean squared error is 68.8. And there are other errors that let's not to get too deep into it. Keep one of them as the, so we calculated the mean square error. Now we want to calculate the root of that mean square error. So instead of 66 point something on the top, 68.8, we are calculating the root of this value. And now the first level of our feature engineering. So what we are trying to do here is, instead of just getting previously the pickup date time, we are going to extract the day of the week from this pickup date time. If you go up and check the base model, you will see that we do not have this line of code here. And this is one of the to-dos, obviously, to go through next time when you are doing it on your own. Yeah. So we are hoping that doing it, yeah, help us to have a better loss. So let's calculate the loss. Now loss is 72.43. Evaluation loss is 88. This is not so good. Mean absolute error is 5.2. Mean squared error is 88. Didn't we had 8 point something before? Now the root mean square error is 9.4. I think we did better job in the baseline. Don't worry about it. We keep going. We keep going. So now we are adding another basically feature to the system. So in addition to the day of the week, we want to add hour of the day. Both of them coming from the same pickup date time that we previously were feeding into the model. So let's see what does it add.
Make a big difference.
I hope. I'm seeing the number and I'm like, oh my God. The difference that we are hoping for it to make is because if we are just looking into the pickup time, it carries the information about the hour and the day both. But when we are just looking at one of them, we don't have all of the picture. So still we are not beating the number. We are at 8.4. And yeah, I think we are really close to the base model, but not there yet. So now we are going to concatenate this information and do feature process. So what it does for us is now we have a combination for every day of the week and every hour of the day. I checked the number just to be sure.
Sorry, can you show the code that's doing the feature procs?
So the concatenate casting, we are getting this value and we are concatenating concat them on top of each other.
Interesting. Okay, so you get two numbers, cast them to string, and then make a concatenated string from that, and we call that whole thing a feature cross. Got it.
So BigQuery class model. If you put everything together, the base model was 8.62. Basically the error was 8.62. We were losing some information where we just included the day of the week, and it makes sense because if you are like at midnight on a Friday or like it really changes. When we just included the hour and the day together, but without combining them together, we improved the model slightly, but we still was not in a good position. finally, by feature crossing, we were able to improve. Obviously, this is just the beginning, so you can continue and sky's the limit with your features. And this is the lab. When you are doing it, you're actually going to the feature engineering labs, and you would see the same thing. But instead of some of these snippets that I just went through, you would see to-dos. Let me find one of them to show you. Yeah, for example here. So this is a to-do part 2, and it asks for you to create that, to extract the day of the week, and you need to write that a snippet of the code that takes the day of the week and generates what day of the week it is from that snippet. And you are just going to do this. To be honest to you, even if you just open it and close it, it gives you the credit, but it's really worth going through every line of the code here, because those lines that are not to-dos and you are not you don't need to do, those are what comes handy when you are coding for yourself. But that's it. So we are, yes.
Is the one hot encoding for the day of the week happening after we created 1 to 7, like in the BigQuery ML?
To the best of my understanding, it doesn't do one hot encoding in here.
Could that be
Yeah.
part of
It
why?
gives it as a number.
I didn't think we did a one hot here. It might be a good idea to do that. I think that might be a way to make this model better, actually, but, well, I don't know if that's true or not. Oh, that didn't sound good.
Sometimes the screen just goes on.
Oh, there it is. So I had two comments and a question.
Yes.
It's worth pointing out that all of the feature engineering and the transformations that we did for feature engineering, these are pretty simple ones, but they can all be done directly in SQL. There's no need to jump out to some other programming language, right? So you're doing it as part of the select. The transformations are done by adding additional columns to the select list that is going back to the original public data source. So that's what's part of a lot of what makes BigQuery and BQML so convenient. If you're using especially using a public data source, or if you have your own, it would be the same thing. The second point, I was going to ask you a question, and I think they cover this in some of the machine learning courses that Google did, but if you sometimes, when you do a feature cross and you find a feature that helps, that improves the model, is it better than to drop out the original columns and just leave the cross, or is it, or how do you decide that? How do you know what to do there?
Truth being told, I would try both ways. I'm not so much of a big fan of feature crossing because I think it increases the size of the input. Here's the thing, if you have a sparse input, then you are having an easier way of training the model, but it's going to be a bigger model. And I'm talking usually about the deep neural network.
Yeah.
My experiment with the traditional machine learning is limited, but with deep neural network, you are generating a giant input data.
So what I remember from, it was a couple of years ago when I took these courses from Google on machine learning, but what I seem to remember was sometimes the original, well, the way you do feature engineering is part science and part art, right? So there is some intuition there. Like if you're doing anything that has to do with distances and you have lat and lon, you can make a pretty good guess that it's actually, like we said earlier, you don't care what latitude you live on or what longitude, but you do care. The combination tells you something about, oh, I want to be within 5 miles of Children's Hospital because that's where I'm working, right? That kind of thing. You wouldn't get that from just the lat or the lon, right? So therefore, my intuition says maybe I should combine those into a feature cross. That's going to be really helpful for me, that kind of thing. And I think what I remember from one of the courses is that sometimes the original contributing columns then just become noise to the model, and you can actually do better by dropping them out and just keep the cross. So that's what I was kind of getting
Definitely.
at.
I'm
If you make a
learning
cross
too.
like that, is there any point at some point of like truncating the precision? Like here your lap one to like 12 decimal places, like maybe 3 decimal places gets you the same.
Well, you can explicitly bin them.
Okay, so it's a binning that might help.
Sometimes binning helps a lot. Yeah, you're right, because you don't.
Like which inch on
Actually,
the surface of the earth
especially when you're doing a feature cross.
Yeah.
You probably want to do binning first because, and that lat and lon is a great example because otherwise you'll have like a zillion points and they're not materially different. So like if you live on, this house or 3 houses down on the same block,
112 Elm Street or 111 Elm Street. Like
it's probably not going to affect the house price. That location distance is not going to be an impact on the house price. But yeah, so good point.
So to come with your points, we drop the original column.
Yeah.
So we drop the original column, like after we feature engineer. For example, the date, we have the year, month, and the date. So we do feature engineering, we get year, the month, and the day, and the date. So do we drop the original column, like the whole date? Do we drop that, or do we just let
I think what Roy is the expert here, so
I'm learning with you. I'm like,
I think she said
so many.
try both ways, right? Especially for small models like this, where it's 5 minutes of training or something or less, or 1 minute. You can just try it.
My point was when you are dealing with a neural network, then something like a feature crossing can increase the size of your input. And if you are dealing with basically densely connected, even if your feature crossing makes a sparse input, meaning that you have a few ones and a lot of zeros, but still training it is expensive computationally. But the great point that Norbert brought up is when you are having a traditional machine learning system, suppose you have a linear regression, you do not want to keep the original features because they would be treated as noise. So if you are bucketizing your system and you are turning them into one-hot encoding, so you are turning this a snippet of your initial data, those giant number of latitude and longitude, they would not really matter to your network anymore. They basically just make them go crazy.
Mm-hmm.
Okay, questions? No questions in the lab, and we were early, and I just did the lab for you.
We're done, actually.
Sorry?
We're done.
Yes.
Woo!
Yes. So I think if you check in here, it says one of the lab is done. Yeah.
The metal cursor went to like 60 out of 970. They didn't use that little counter that counted every single thing you've done. It makes it a little more depressing now.
I take note for myself, and yeah, I just like check mark everything. I think
So what's next?
we don't have anything else planned for tonight.
Talk about next week or next session.
We do have a Kahoot if you want to do that.
We do have a
We can
Kahoot,
do a
yes.
Kahoot
I was
first,
like,
right?
why we are early? It doesn't make sense.
And we also have a lot of pizzas. And
Yeah,
people aren't
pizza
allowed to
prizes,
leave
yeah.
until-
You gotta eat all the pizza.
Everyone gets a pizza. Check under your chair.
You get a pizza. You get a pizza.
I was referring to this little slide that shows how far I am. Oh wait,
Yeah.
I used
With
to
the whole-
wait. I did way more than that. What the heck? 2?
Maybe it sees both of them. I didn't
It
honestly.
gets confused when you have multiple learning paths going on at the same time.
Okay, yeah, no, I'm like 65, not 2.
Yeah, 2's not good.
No, I must have
I
lost
kind
one.
of poo-pooed the field badges last week, and now I started collecting them. As she said, why not?
Yeah, I mean the badges, it gets a little addictive. You have 6 of them, you want to get the other ones and finish it out. It's kind of fun.
One thing I noticed that, so I'm really getting more and more impressed with Skills Boost because for some other projects that I'm doing, I have to learn
I didn't know
about
that.
There you go.
networking, which I took one of the, it's very similar to what we're doing here. I took one of the diagnostic quizzes that has 10 questions. And it's like, on one of those, I got like a 30%.
Okay, I'll stop sharing so you guys can't see the answers ahead of time. 1 second.
Okay,
I was like,
don't know
you
if
are
it's-
so
right.
great
I
sharing
don't know if it's
everything.
Google networking.
Does it like tell you which courses you need based on that quiz, or does it just tell
Well,
you?
it's interesting. The
the
skills
one?
boost in a way would, and you can tell me
Yes.
if I'm
Okay.
mounting out right here. Traditionally, Google has
So-
had their training courses that you can get from Coursera and Pluralsight, and they're moving a lot of those onto Skills Boost now. But what's really helpful if you
So,
follow
Lucas,
a
did you put it in
certification
90
track
seconds or?
is that Skills Boost is putting a
For
whole
each
layer
question.
of stuff on top of that, around the courses. So you do this diagnostic track first and get kind of like a feeling for where your weaknesses are, and then they tell you, oh, you want to study this or not this stuff or whatever. I'm kind of, once I decide to do something, I kind of tend to do the course that's cover to cover.
Okay, so
You
here's
know,
the Kahoot for
That's just
today.
you know, but if you already know a lot of this stuff or know half of it, then you don't want to take the whole course. And so the Skills Boost wrapper, so to speak, lets you drill into the particular stuff that you need without doing everything. I'm kind of more of a, I just want to.
I mean, to be honest, like just to briefly pitch the Skills Boost, what is it called?
Innovators Plus.
Yes,
thing
plug it,
again.
please.
But like, you know, having access to those labs means you could be, instead of just thinking of it as like, oh, I'm always working towards the next certification. It's like, oh, I'm gonna have to work on this GKE cluster at my job next week. Let me go like
Maybe there's a lab for
do
that.
one of the labs,
Yeah.
and so that when I go into the meeting, I know what I'm talking about.
Right.
And so you can be very tactical and just like learn the thing that you're trying to do instead of go read a quick, you know, Stack Overflow answer about the question you have.
Yeah.
You could just go do a lab about
There you go.
it, you know,
We'll take
and it'd take a little more time. But if you have
45
that
minutes.
Innovators Plus thing, you know, the cost of the credits is not an obstacle. It's just like when you can make the time to do it. So highly encouraged.
If you were going to pay $200 to take the exam, if you get this for $299, you get $500 to spend on Google Cloud whenever you want. That lasts indefinitely. You get the credits. You get the voucher to take the exam. That's $200. If you pass the exam, you get another $500.
And another voucher.
And you get to take all the everything in here you want, as many credits as you want all year. So that's hundreds of dollars there. So anyway, just noting there's like $1,200, $1,400 value here.
Yeah.
And if you're going to take the exam, it's just $100 more. So like Lucas and I both use this, but it is really great when like as Lucas pointed out, I'm about to do something like I've never done before at work, and I don't want to break anything. Okay, I'm going to go to a lab, watch a few videos, do the lab, and it's in a place that if I blow it up, it doesn't hurt anything.
And sometimes it's just, you know, literally like opening the console, clicking the create, like filling in the values in the boxes yourself. You learn it better than if you're just reading a doc about doing it. And so I think having, you know, use it like we're describing right now because you have access to this pool of credits. So just use it all the time. But if you choose to after the program's over and you want to invest in the credits yourself, it's well worth it.
Yeah, one thing because I'm a Google trainer, I've often brought up the traditional path that Google has outlined, which is there's instructor-led training that you could get from the training partners. That's really good if you bring a whole team up to speed all at once. You bring an instructor onto your campus or whatever, that can be really effective. Coursera and Pluralsight have been the traditional on-demand vendors, but as I found out yesterday, Pluralsight has not updated their courses to the new version. So like for the PCNE, the Professional Certified Network Engineer track, Pluralsight has the old, I actually took the entire old course on Pluralsight, and when I was finished, it said, oh, by the way, there's a new version of this course.
Oops.
But you're not eligible to get it, and you have to upgrade your account.
Oh my gosh.
To the pro level for
terrible.
another $200. I said, no, I can just go do this on Skills Boost.
Skills Boost does it automatically. I remember we were near the thing we did last year, and it was like, do you want to upgrade? I'm like, wait, do I lose my?
Yeah.
But anyway, we'll get started here with the Kahoot. I think we got a ton of people in here already. So do you want to lead us off there, Roya? Just click on start.
Thank you.
And you're gonna have 90 seconds with these questions. All right, 90 seconds.
if the business case is to predict fraud detection, which is the correct objective to choose in Vertex AI? Clustering, forecasting, regression, classification, segmentation, feedback. And you have 90 precious seconds.
So you're saying I want to look at something and tell you if it's fraudulent or not. Okay. Because my bank does a terrible job with this. I bought the pizza. I bought the pizza for this night, and they were like, fraud.
False alarming all the time.
Yeah.
Which bank? Don't say that.
Barclays.
No.
They're super cautious. They've set their threshold on the AUC curve in the wrong place.
Because someone stole my credit card and shipped pizza to me.
Precision recall question.
30 seconds. You got 17 answers. Take your time, y'all.
We didn't show what are they.
Prizes? The prizes are 7 cheese pizzas.
We have
Everyone gets a
whatever's
cheese
in the swag
pizza.
box.
Oh yeah, Google developers fanny pack. You cannot buy these in stores. And a Google mug. And we'll find something else in there.
So I didn't bring it. There's
So-
more of those phone charger
Oh,
things.
okay, cool. So what's the right answer here, Roya?
So the right answer is basically classification. The idea is you have all of this information and you are just trying to make a binary decision whether it's fraud or not. And so clustering, forecasting, they don't even make sense. Clustering is when you do not have the information whether it's a fraud or not. Forecasting is for based on the previous information, but then it's when you want to decide about the future of the same nature. So it doesn't fit into this category of binary yes or no. And segmentation usually comes when you are dealing with image data. So that's not the answer. Also, regression classification is the correct answer. Kudos to the 12 people who got it right.
So for forecasting, they'll be like, what's the temperature going to be tomorrow? Right?
Yes.
It's like it's more on a continuum, not like a binary case.
Exactly.
So we click next. We'll see who did well here. Okay.
Do we have
Volkan up here.
Alex is here? Volkan, you? Oh, okay.
We actually have some folks in India joining us. So.
Oh, okay.
All right, next. Yeah.
Next, question 2 out of 5. How do you decide when to stop training a model? When your loss metric starts to increase, when your loss metrics start to decrease, when your loss metrics start to both increase and decrease, none of the options are correct.
What about when you run out of money?
Kind of lost metric.
And the P&L.
Boss shut down the project.
We have the 17 answers already. Do we have
Are we-
17
we-
people?
Can you let them play?
I got 18 answers.
Okay, everybody answered. So the answer is when your loss metric starts to increase. When your loss metrics start to increase is when your model is getting overfitted and you are calculating the loss for your validation set. You are seeing it obviously in the labs. So basically your model is memorizing the training data so much that it gets further and further from what the reality is. For that exact reason, and none of the other makes sense. I want to also point out that when your loss metrics is bouncing and going up and down, it is not you obviously stop the model, but keep in mind that's a good metric for reducing the learning rate. If it's bouncing, it means that it's close to the local minima. It doesn't hit there. So it's a good time to stop the model, change the learning rate, bringing it low, and then continuing it. And hopefully by doing it, the bouncing loss function would go further down.
Make smaller steps, in other words.
Exactly.
Got it.
So 9 people.
Oh, Alex.
Yay!
Nice.
The user one's close.
Yes. So next question.
I like it when it's a tight competition.
Totally.
If a data set is presented in comma separated values CSV file, which is the correct data type to choose in Vertex AI? Image, tabular, text, or video? We have the 18 answers.
I think it's video.
It's tabular.
Oh. So why is it not text? No, I'm just five people said text. So why would we say it's not text?
I don't know. I just know
Because
it's
tabular
tabular.
is a better answer.
So if there weren't columns,
I mean, it's
if it was like freeform text and it didn't have columns,
Yeah, I mean, I think that the text in this scenario, because of the tabular, is implying like it's paragraphs of text or something rather than like a table.
sure.
But
just like on the,
So
on the
unstructured
exam,
data.
on the
by
exam, you know, that's a
definition.
plausible answer, but there's a better answer.
Gotcha.
That's how I would look at it.
I didn't. Honestly.
Let's see. Is Alex still there? Oh, pulling ahead. Oh, not that far. User one is close. Vishwa's in striking distance.
It's all in the timing, right?
Yeah.
Yes.
I don't want to distract Alex. Okay, he's in the zone.
You
Oh, I got the mouse. Wow.
gotta buzz in quickly.
It was from the quiz, so there's a familiarity factor.
Which are the distinct ways to create a data set? A data store constructs a data set from data stored in memory or in one or more files. A data store constructs a data set from data stored in memory or in one or more files and a data set. A data transformation constructs a data set from one or more TF data set object, and none of the above. The orange one is a combination of the red and the blue. That's the rest that it's fallen.
So it really should be purple, is what you're saying.
Yes.
Oh, you already got one? Well, a fanny pack. I've got one of these at home.
we can cobble together something else.
We got other stuff here.
And we have other things at home that we can bring in.
Small apartment.
Did I already give away that chrome pillow? I think we gave that away at the
Chrome pillow? What?
Did we give the chrome pillow away at the Women's Day event or something?
I'm not sure.
Okay.
We got 20 answers.
That was a classic.
Shit, close out. Maybe someone joined it. Okay. Oh, okay. It's a tight race.
Yes. Okay, so for everybody who chose blue, I'm sorry, because basically when you are talking about the dataset object, and I try to really make it clear when we were going through the slide, it's for you to be able to both catch the data, like basically fetch the data from the memory, but also to be able to apply all of the transformation you want. So a dataset object, the reason that you are creating it to get the best of both worlds, to be able to load this data in addition to apply all of the transformation. I really tried to make it clear when I was giving the slides. So the right answer is the combination, which is the orange. And let's see who's the winner.
Uh-oh.
Do we have one more question?
Yeah.
There was 5, right? 5
Yes,
questions.
5 questions, yeah. Okay, one more question.
Got that one wrong.
Which of the following metrics can be used to find a suitable balance between precision and recall? Positive rate AUC, ROC AUC, log loss, F1 score.
That's wrong.
Can you change?
I don't think we
I
talked
don't think
about
it's
this today. Did we?
I think there is a option that they can change. Like
No, but did we talk about this today?
it was from last week.
Last week.
Two answers to go.
These are based on the content that the attendee is supposed to study throughout the week.
Oh, I see.
For
Pop quiz.
I was like going back, make sure. I
Is this
got
talking
them,
about a
trying to remember
GPT
quiz,
model?
And then I was like, I was skipping the labs, man, to skip the quizzes. I learned the videos for the week, and I'll go back and do the labs.
I often binge watch the videos and then
Yeah.
come back and do the labs. Yeah, that's a good way to do it sometimes.
If you're gonna take the exam, I just make sure you try to complete all that stuff before then.
Oh, yeah,
Yeah.
I try to complete.
Yeah.
before
But, like,
next session.
Hey, you know, I just mean to say, again, it's good to like learn the theory, but then you can go back and do the labs because you get that hands-on, you know, that muscle memory, you know, seeing it in action. All right, 10 seconds here.
The one that I was looking at, the so-called diagnostic quiz that tells you like for a year or a week, those questions are really hard, I found. And they're actually, I think, very similar to the exam questions.
So what's an F1 score?
This is actually a part of the course that is exactly written. This is a combination of the precision and recall and makes the balance between the two. And that's why that F1 score is the right answer.
So where did we fall? Let me see the final tally. Here we go. Who's on the podium? Good job, Alp. User 1.
Who is the user 1?
Who's in the room? Man? You have to be present to win swag.
Do
Now
we
the
have
people
any-
online and doing the coursework.
Yeah, they're all busy doing course.
Do you know how to bring?
Other than you.
So who is MK? Reveal yourself.
Claim your prize. Michael. Congratulations, Michael.
Congrats to
Chasm.
Michael. Yes, congrats. So congrats to everybody there. Who would have been our top 3 in the room here? Let's see. Let's go to the end here. Can we share the podium?
How do you tell who's in the room?
You have to ask them. So we'll be in the full report here. They say
Yeah, we haven't been doing a good job of checking the physical people.
Maybe we should make people prefix their names. If like,
So here's everybody.
I don't know.
Give everyone a color.
Congrats to Frank, Alex.
I've always wanted to be
Welcome
one
back.
of them.
So Alex, do you want the fanny pack?
Let me look at it.
You can check it out.
I mean, if you already have one, then,
I
then
think
we'll
we
find
should-
something else
I
for
think
you.
we should do it so like everyone can get swag.
Okay.
So
Sure. Yeah, you got.
forego.
I'm in fourth.
You're in fourth?
You're in fourth.
Yeah.
And
Oh,
you're
sorry.
here.
You're
And you're here.
Which one?
That's good enough.
Would you care for something from our swag box here,
Pizza.
The mug is pretty great, actually.
or a few pizzas? A Google mug.
I will take some pizza.
Anything.
There you go.
I have a man at home who will be really mad if I tell him there was pizza.
Cool.
Okay.
If any of the contestants here need something, feel free. Thank you so much to our remote folks. So glad you can be with us here.
Yeah, it's really quite a good turnout. I was like surprised to find out that several people got blocked by being on the waiting list. And I was like, waiting list? What is this? And then I checked and we had, like over 120 something signups for today. So we're gonna have to be more attentive to the waiting list to make sure people don't get blocked, or maybe we'll just increase the virtual signups limit. Let me reshare the slides. They were earlier in the chat, but I don't know if people can go back to like super far in the chat. So let me reshare them
Put it
again.
in the Slack channel.
Yes, I will share them in the Slack channel.
The slides are being shared and also the video.
Joe will upload the video. And I don't know if you noticed, but we did have a suggestion in the chat that YouTube is a freely available service that you can use to upload videos. So maybe if we could post the videos to our YouTube channel as well.
Yeah, totally.
That's a great suggestion.
I was so careful today not to say anything, so you need to do editing.
Oh yeah, not a lot of editing happening
Luckily,
after.
nothing failed on us today, so the gods have smiled on us.
Remarkable.
But the only thing I would just stress for folks is, I know it's easy to forget, but just make sure you sign up for week 4. Because
Yes.
otherwise, like, the way they designed the software, it's like the tick after the thing starts, you can't sign up anymore. So people are like, hey, I can't get
Oh,
in. Well,
yeah.
I'm sorry.
Yeah, if you
Yeah.
can right now sign up for week 4 if you're planning to
We
attend,
could-
just
we
get
could
it
log by
done.
ourselves.
Make sure you sign up through the GDG interface and not through Meetup because that's how you get access to the credits.
And the credits basically extend from like the last
Yeah, and then
thing
they
you
just
signed
keep-
up for.
They keep. I think what they're doing is like adding people to a Google group and then not removing them because they joined the next session. And so that's how you're getting access to
So
these
sign up
credits.
for 4. If you really feel great, sign up for 4, 5, and 6. But that way you make
Yes.
sure you don't find yourself out in the rain at 5:32
Mhm.
p.m. when they
Yeah.
won't let you in.
Yeah.
But otherwise, I think that's all we got.
Yes. Thank you so much.
Thanks, everybody.
I'm glad. Thank you all for people who gave feedback about the date change. We were like struggling this morning. Should we change the date schedule? Should we not? And we were like, maybe we should poll the audience first. But we got a lot of positive feedback. People seem that it's a little stressful trying to do all the work within 1 week. So hopefully this is better. And so we'll see you all in 2 weeks. And in between, we'll see you in the Slack channel.
Yes.
And I'll just say another, like, just a quick round for Roya again, who
Makes a lot of this
Yes.
content, who leads us through it. So thank you so much.
Thank you, Roy.
Thank you very much. Thank you for bearing with me with all of my inexperience, my pronunciation. I really appreciate it.